welcome back. We've got a lot of algorithm problems in the Pipeworks, but I wanted to stop and address some of the coronavirus concerns, and more specifically, that there really isn't a lot of data sets out there that are being updated regularly for the general public and for engineers at large who want to make their own decision and assess the numbers and check the trends. And there's a lot of information coming in every day. You know, we just learned that the incubation period is around 5 days, and that even before people start showing symptoms, they're extremely contagious. The virility of this disease is pretty staggering, and additionally, a lot of anecdotes from all over the world. More specifically, more recently, Italy, who is being devastated economically by this influx of cases. So those are pretty bad stories, but nonetheless, they're anecdotes, and really can't make an assessment on them. But I did stumble upon this. John Hopkins Whiting School of Engineering, since the 22nd of January, has been updating a repository every single day that has a lot of good information. And you can go on John Hopkins' website to see the Whiting School of Engineering, to see where they're pulling these sources from, or this data from. And a lot of it's from the CDC and WHO and a couple other sources around the world. But I think it's a great resource. So this link will be in the description if you go to this link. And what I wanted to do today is show you how to extract this data. It's going to be a CSV file, and you can work with it directly if you just wanted the CSV file. But I'm going to teach you how to get it to your own site. The files are a little bit large to be doing this on a massive scale. But if you just wanted a daily update, I think this would be a good way to do it. And maybe you clever engineers can figure out something cool to do with it. But if you go to their repository here, and this is one repo, COVID-19, and go to the CSSE COVID-19 data. Daily reports, they're being updated every afternoon, say around 5 or 6. Today this is the 11th, and so it hasn't been updated yet. But if we go to one of these, you'll just see it's a CSV file, and we have province, country, confirmed, cases, death recovered, and some coordinates if you wanted to map this as well. So again, I think this is a great resource. If we go to the raw here, you'll see that, yep, it's a CSV, comma separated values, where the columns are separated by commas and the rows are rows. So it's just a condensed Excel spreadsheet. And yeah, so I'm going to teach you how to get this data onto via JavaScript onto your browser, and because you can't just do a fetch on this raw HTTPS on this URL without a header, or else you'd run into some sort of CORS. So we're gonna show you how to get around that, as well as because they're only updating this repository every single afternoon. If I did a search for today's date, the 11th, I would get a 404. So we're gonna do some clever things to get around that, or to check for that. So yeah, I just wanted to share this and help you make an informed decision on your own. But yeah, let's get into it. Okay, so I've got a simple site here. It's just HTML, CSS, and vanilla JavaScript, and we have a button. And on click, we're going to define a function called runCall that's going to call our API. And a couple things here. So if today doesn't exist, we're going to recursively try our fetch again. So if I fetch today, today's the 11th of March, if I fetch for today, I would get a 404 because that file doesn't exist yet. So what we'd want to do is recursively call that, decrementing the day from our date string. And second thing, if we don't have a header to this fetch, we're going to run into some CORS responses. So there's a cool little trick in Postman. If you get this is our API call here. We'll copy that. This is from the GitHub. It's a raw file. We go to Postman, and you see I already have that here. If we did a call here, this is for the 7th. I get the same response that I did in the browser. But if you fetch this in without a header, again, you'd run into some problems. So a cool trick here is if you go to this code tab, what you get is a bunch of specifications for a bunch of API calls. So all in different languages. So you can see what the headers are and what the actual code is for a bunch of different calls. You know, you have a PHP curl, you have a PowerShell REST method, you know, a bunch of Python methods, and your standard curl. But what we're going to use is the JavaScript fetch, and right here is our header. So all we need to do is, you could straight up copy and paste all of this. You'd get the same thing. You get the exact thing that you're calling right here. We're gonna drop these then statements and use async await, but we are going to use this request. So all it's doing is fetching the URL, and then the second argument to the fetch is a specified options, so the header. Okay. So let's do that. So our first, what I call this, run call. Let's define a function called run call. It's not going to take any parameters. All it's going to do is we'll call this API value, and this will be this is where we're going to call our recursive function. Okay, so it's going to be an asynchronous function, so this needs to be asynchronous, and we'll wait for the result of what we'll call fetch retry. And it'll have some default parameters, but we'll leave that blank right now just to not be confusing. So we're awaiting the result of that fetch retry. Then at the end of the day, we're just going to console log that API value. Okay. Now let's define our fetch retry function. It will take a parameter of the number of days that we want to decrement from today if today's value, the API value, does not exist. So if I get a 404, then we're going to decrement n number of days starting with 0. This is going to have our fetch call inside of it, so this will be an asynchronous function. What's the first thing we want to do? We want to define our Postman header, or the header we got from Postman. So I think they just called it request options method get. I think it's redirect follow, and then our URL. So we'll call that API URL, and we'll make that a template literal, and we'll get that from the raw file. Okay, so we don't want this. We want to make this modular. So instead of having this date, we'll define a function called get date string or something like that. And that will pass in our number of days that we want to decrement as well. And all this function is going to do is get our date into a string. So let's get that all in one page. And let's go ahead and create the shell for that so we don't lose track of it. So const get date string is a function that we're passing in n days to decrement, and we want to return a string of the form month dash day dash year. All right, we'll come back to that in a second. So once we have the API URL and the request options, all we need to do is fetch for this thing. So we'll nest our fetch into a try, and we'll call our response. can't spell, is equal to the awaited value of a fetch. This is an actual fetch call, and so it is asynchronous. The first argument would be the API URL. The second argument would be the request options. And at the end of this try, we'll return if the response is okay, meaning if the response is anything from 200 to 299, and it returns a Boolean true, which means that the response was okay. Well, relative to as far as the server is concerned, response is okay. We'll return the response text body. Else, we will recursively try our fetch again. So we'll call our fetch retry using n+1. So we have a default value of 0. If our response body is a 404, we will recursively try our fetch retry again with n equals 1. So n being the number of days we want to decrement. All right, that should do it for our try. And our catch, just have an error. We're not going to do anything with this error. We'll just console log it out. And return null. Okay, that should do it for our fetch retry. Let's define our getDateString function. First, we want a date, and that's going to be new date. And we're going to define the new date as the date in milliseconds. So we can use date now, and date now is takes the now date and seconds and everything in milliseconds and subtracts it from, I think it calculates it from like January 1st, 1970 or something like that. But it's a more precise way of getting the exact date because it's all in milliseconds. So for doing that in milliseconds, we need to convert days, n days, into milliseconds. So we'll define a function called days. Well, we want to subtract days to milliseconds here. And we'll pass in n days, and we can just define that real quick here. You can do this inside of this function as well if you wanted to. We'll do it here for simplicity. Days to milliseconds will be a function that takes in n days and returns milliseconds. So n days times 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute times 1,000 milliseconds in a second. So that just outputs milliseconds, and that's our date. And now we want to format because we don't want what the standard format that date gives us. So we'll define a variable called format, and we'll use an object called the intl. And I think it's sort of like an international standard. But you can format a bunch of things. What we're going to use is the DateTimeFormat. And there's a little cheat sheet that I'll link in the description. But read that doc and it'll explain everything that's going on here. But the DateTimeFormat method takes in the region or language and an optional format. So in the doc, you'll see that you can either have 2-digit, numeric, a bunch of options for how you want to specify this format. So day will be 2-digit, month will be 2-digit, and it's 2-digit because if the month or day is less than 10, we still want that 0 in front of it. And then the year will be numeric. Okay, so it's kind of hard to see what this is, but I have the exact same thing written out here. So you see that it's the same thing except we don't have our date in milliseconds because we don't need it right now. But I just wanted to show you what this looks like. all we're doing is console logging this this format that we just wrote. So let's call it test, and you'll see we just get an empty object, right? But in the specification we have it inherits some properties from the INTL. So if we did a method on this format called format to parts, and we passed in the date object that we created. Let's console log that out. So what does that look like? That gives us an array of objects where it's just basically our date that we're deconstructing, and we're putting it in this format. So you see that we do get a 2-digit month value. We have keys of types and values, and the value of that is some strings. So what we want is what we really care about is the month object, the day object, and the year object. Or in this form, I guess it's the 0th index, the 2nd, and the 4th index. We don't really care about this literal value, right? We don't really care about that. We want dashes on our string template. So what we can do is just since this is array, we'll just do some array deconstruction to get this and this and this. Okay. So we'll use array deconstruction, and let's zoom in here. Go down with this. And we want month, 2 commas, because we don't care about that literal. Day, 2 commas again, and year. And that's going to equal what we just had, format, which is the constant we defined, and format to parts, which is the sub method on the INTL object. And we're going to pass in our date object that we defined. Okay, so given that, we can just return from this function our string. We'll have that as a template, and we'll say a month dash day dash year. Okay, so I'm specifically making a mistake here, but I want to show you what would happen if I got into an infinite loop of fetching this recursively. So let's try this. I think this will do it. I've got the console pulled up here. All right. Yep. So we are now in an infinite loop of recursively calling this fetch retry, which is obviously not good. And you'll see that my string template was wrong. I've got an object here, so it's telling me the type. All right, so let's force close, and let's get this open again. Okay, so it turns out that that what I did here is I defined, since I broke this object up, this array up, this entire first object is what I called month. So what I really want is month val and day val and year val. So let's do that. Okay, so that should do it. Okay, so you see we get a 404 on the first call for the 11th, which is today, and that repository or that file does not exist in the repository yet. So what we did is we recursively called it with n+1, and which decremented our day by 1, and now we're calling the 10th here. So let's do a really quick code walkthrough. Well, actually, I want to fix the infinite loop. So one of the biggest reasons why I showed you that infinite loop is because we need to handle that. You can't just have infinite loops, especially when you're calling APIs. So let's define a max retry integer. And we'll set that equal to 15 for now. Okay. And in this ternary, we can, instead of saying returning the recursive function, we can say if the response body is not okay, or the response is not okay, what we'll do is check if n plus 1 is less than our max retry. If it is, then we will then call our fetch retry, and if it's not, we'll return null. Okay, so that looks pretty ugly if you've never seen nested ternaries. Me personally, I like this. I think it looks pretty clean, but I can completely understand why you would not like this. Sometimes it's written like this. I think Prettier will reformat this for me again. Yeah, so if the response is okay, I'll return the response text body. If it's not, I'll check if n plus 1 is less than max retry. If it is, then we'll recursively call fetch retry with n plus 1, and if it's not, then we'll return null. So personally, I think that looks clean. However you want to do that, and you can nest some if statements in there if you wanted to. But okay, so that works, and you'll see that if I got the URL wrong, then I'd get, I don't want that. See that I get 15 calls to the API or a URL, and then I return null. It gives us a little safety there. And you know, you can optimize that. There's other clever ways to handle this situation, but you know, why would the API call fail more than once? Maybe Johns Hopkins stops updating the repository, and this is you want this to last a couple of years or something like that. Okay, so one last code walkthrough. We're defining a function called runCall. It's an asynchronous function that gets called on click of this test button. We're instantiating a constant API value, which is the result of awaiting our fetch retry function, and then we're console logging that API value. Our fetch retry is also an asynchronous function with default argument of n equals 0. So n corresponds to the number of days we want to decrement from the current date. We have our header from Postman. We've defined a max retry integer. We have our API from GitHub, and then we're nesting a fetch into a try. If the response is okay, meaning if it's 200 to 299, the server says it's okay, so we'll return this response text. If it's not, we'll check if n plus 1 is less than the max retry integer that we defined up here. If it is, if n plus 1 is less than max retry, we will recursively call this fetch retry again, incrementing n, or decrementing our date. If it is not, we'll return null, and then we're doing some mediocre error handling here in the event that it goes sour. And you can read the documentation on what constitutes a failure with a fetch. It's essentially any response from a fetch is a success. So you do need to do some checking, like response okay, or know exactly what type of response body you're going to get back. So you can do some checking if you wanted to check further. Inside our URL, we're defining a getDateString function. It also accepts the number of days that it's getting passed in from the parent, and it just uses a date now and a days to millisecond quick function that we defined. It's used the Intl object to format how we wanted our date to be in. We're doing some array deconstruction to get month, day, and year, and we're returning a template literal that is in the format that we desired. Okay, so that's it, guys, for this video. In the next video, what we're going to do is map this data. We're going to compare it to some other viral diseases and some other causes of death, and maybe see where the trends are going. So what I've been specifically looking at is the data in South Korea or other metro regions in Asia where the testing is very high. So the number of tests they're doing every day is consistent and it's high, and that eliminates that moving variable. Whereas in the U.S., our testing is so far behind. Our CDC never approved or was slow to approve the testing methods, so we're a couple weeks behind. So the U.S. data here is, afraid to say that it's not going to be a real representation of what's going on. But yeah, so you now have access to this data. You can do with it what you want and make a better informed decision on if you should be worried or what precautions you should be taking. But yeah, happy coding, guys, and stay safe out there. Bye.